Yeah.
Ready? Okay, pressing the button. Okay, we are live. Hello, everyone. This is Nikolai and Ilya with a new episode of Postgres TV. And
Hi,
today,
everyone.
hello. And we today have interesting guest, Jan Karremans. Sorry,
That's perfect.
From Nether. It's even more difficult for me to pronounce. Netherlands. Can you pronounce it correctly for me, please?
Netherlands, or as the Dutch say, Nederland.
Yeah, I know that we cannot say Holland anymore, right? It was much easier.
It's a part, but that's actually a part in the northwest of
right. Common misconception. And we are going to discuss today Postgres and Kubernetes. Also, these words I know, at least, right? Also quite difficult for many because they both consist of 10 letters, as I've noticed. PostgreSQL and Kubernetes. And let's just start with some maybe introduction. Can you please?
Yeah, I think the good question is that many people know Jan as an Oracle expert. So, what happened? How you ended up with Postgres?
That's actually, thank you. That's I think might be a very interesting question. And actually, as many things in life go, it's just coincidence, things that come together, right? After being in the Oracle space for quite a while, at some point I was working for a company. I did some extracurricular activities, and it was 2015, end of 2015. And I was kind of done with what I was doing at that point in my life. So I said, I'm gonna quit my job, quit my extracurricular activities, and kind of stop. So I stood there and actually, what to do next. Then, through my network, at some point, I got the opportunity to actually go to Hamburg. So I went to Hamburg to do some consulting work that ended up, being in a company, running a company, but it was still in the Oracle space. But at least I was free from this kind of traditional workplaces that I was in. But it also meant that after 2 years, that job was finished. And actually, I had moved from the Netherlands, from Holland, to Germany, so living in Hamburg. And my neighbor in Hamburg actually at some point said, hey, you're stopping at your current gig there, and I got this message from this recruiter, and there is this company that is looking for people to come do something with this technology called Postgres. I thought that's fascinating. I've been in this Oracle space, and it's convenient. It's a settled life. I've been doing this for a very long time. Can continue doing this until my pension. But one of the things that was already very clear was that it would be boring, right? Because in the Oracle space, actually, no real new stuff is happening. You had seen that coming from the early 2000s, where diversification in the Oracle realm was already happening. So they were not focusing on database technology anymore. It was applications.
But how about automated autonomous database? There was a big hype a few years ago that Oracle has like automated addition of indexes, advisors. Advisors exist a lot ago already, but like fully autonomous database in their cloud. This was a thing a few years ago. Right?
You said it good. It was in their cloud and it was autonomous database. Right. But what the fine print only said was, autonomous database means that you can only run it in Oracle Cloud environment, and it's actually dependent on a big AI infrastructure which is behind it, which monitors the database. So it takes away a lot of these mundane tasks, but it's not exciting for technologists in that sense, right? Because it's done by Oracle, it's implemented by Oracle, and you can look at it, you can play with it, but it's not revolutionary different. If you're perhaps, and this could be controversial, if you're inside the red bubble, it might feel like it's cool and innovative. But if you start stepping outside of that red bubble, that's what I've learned after the switch, actually more even than being in the bubble before the switch, is that, you know, if you're working with a specific technology, then the comparison, when you're a hammer, everything looks like a nail, pretty much kind of plays in. So if you're in the Oracle realm, everything is an Oracle project, right? And as soon as you start stepping out, that changes. And that was, I think, something that I anticipated, or I don't know specifically, but I was bored with the Oracle bit and just sought an opportunity to do something else. But then, you know, this Postgres thing presented itself, but I thought, well, let's just try it, right?
So it's quite interesting. What was your first impression of Postgres bubble? Because for me myself, it was like I finally found improved version of SQL Plus, and PSQL is definitely much more convenient. And second one, I do not miss any typical Oracle consultancy. Then you spend half of your billable hours in scrutinizing licenses, optimizing licenses, and this thing. What was your first impression about Postgres after Oracle bubble?
The very first impression, and I distinctly remember because I actually asked a colleague, like I was setting up my very first database. It was in this database world, your age is always determined by which version you start with. So I'm a Postgres 9.6 person. So my very first Postgres database that I set up was 9.6. And my very first impression, to answer your question, was, Jesus, this is too easy. I'm doing something wrong, because it literally took me from never ever having done this before to getting that first database actually be able to log in. Took me 10 minutes. I'm missing like 10 vital steps here or something. So I actually asked one of my colleagues, like, you know, I've set this up and it's running, and I can actually query the database and stuff like that. It looks, but you know, I only spent 10 minutes. What am I missing? And he said, well, you're not really missing anything. You've done it correctly. I'm like, okay. So, you know, a lot of that complexity that is available in the Oracle.
Yeah, many people just stop on the tunnel in SSH, Lake server for SSH, yeah. To start with. I don't know if it's still there, but well, it was like, for many people, it was like already an exercise to do. Yeah, it's interesting impression. So
and then obviously you trip in over the standard pghba.conf in the time, obviously, but you know, that's another story altogether.
So there are some quits in Postgres bubble as well. So
yeah.
to be completely honest, there are. Yeah.
Nothing can be end-to-end always perfect. There's this nice English expression, the one end all or something solution. I don't think it exists, but at least, you know, being able to not have to deal with complexity which is created just to keep a consulting ecosystem satisfied is something that I found was very nice.
Mm-hmm. Many actually ex-Oracle admins, then they try Postgres, and they do that quite commonly now. So it's like a very typical situation. Some of them are excited, as you and me. Some of them starting to to just complaining that we miss this one, they miss this one, and sometimes it's like very useful things which Oracle is good, yeah, like diagnostic, weight interface, things like this, and sometimes it's not. What is actually, what sort of advice can you give to the colleagues who just starting from Oracle to Postgres? What, like 3 things they can do to improve the experience?
I think very practically, if you're an Oracle DBA and coming to Postgres and you come with the mindset like, you know, I am going to be an Oracle DBA on a Postgres database, well, you're in for a cold shower. Very simply because the Postgres database is not an Oracle database, right? So the first mindset is, you know, I am going to be a DBA, a database administrator, not an Oracle database, not a Postgres administrator, to be a database administrator. And then in that mindset, you come to Postgres. What that will allow you to do, and perhaps there are not 3 tips or tricks, but more like a general mindset kind of thing, is, you know, if you then start looking at requirements that your job asks of you is to run blindingly fast SQL queries, to, you know, start answering database provisioning questions. You will find that the Postgres database gives you a lot of opportunities to actually answer a lot of these requirements a lot better. If you, and so provisioning, for instance, provisioning Postgres databases just by the way that it is, the abilities to, you know, with Ansible scripting, with a lot of these other deployment methodologies, including Kubernetes, allow you to set a Postgres database is extremely fast and extremely automated, puts you like 2 or 3 steps ahead from using an Oracle database, because, you know, it takes more time. There might be less hooks and options to automate things. There are more and other challenges. So if you look at this from, you know, a blank perspective, from a database administrator perspective to the product, I think you will find that Postgres, also from a DBA perspective, is a lot more malleable than an Oracle database or another database altogether would be, perhaps. Does that make sense?
Yeah, it makes sense. So it looks like people who allow who made these possibilities real, they were just doing things to themselves. So basically, okay, we like to use automating tools like Ansible, things like this. Let's add alter system, which is useful to use with some sort of automation, for example. Why not? So it looks like this. Well, basically,
yeah. One of those, you know, one of those distinct things is you've got in Oracle, one of the distinctive features would be Oracle real application clusters, for instance. If you come to a Postgres environment saying, you know, I want to run Oracle real application clusters, and now I've got Postgres as a toolbox, that might be challenging because there is no one-to-one equivalent for that technology in Postgres.
Do we need one?
My take on it, not really.
We now have much better computers than in times Oracle introduced Track.
And we have a lot. So this is actually a very fascinating thing, because if you look at that, you know, the one thing that Oracle RAC actually does that Postgres will never be able to do because of the way the architecture works is transparent application failover. So transaction guard and things like that. If you start looking at the number of implementations that actually use that to the way that it was designed, it is extremely few. And in most cases, it actually makes more sense to do that safeguarding one layer higher in the model, in the architecture. to do that at an application layer, because things with transaction guards and transaction numbers and stuff like that, in extremely rare cases, only there are use cases where you actually would need to have the database also be able to manage that. And that's like 0.1% of all use cases or something.
What I commonly saw, it's like people are using reapplication cluster just to do smooth upgrades. But in Postgres, there are many ways to do upgrades. Yeah. So it's basically, if we're talking about this substitution, well, it could go wrong. Yeah, we all know how badly could be things with PG upgrades. But basically, with upgrades in real application cluster, it could be tricky too, as far as I remember.
There are many real application cluster implementations where you would do a failover, the entire cluster would crash.
Yeah,
this doesn't really help very much then, and no. that also kind of comes back to that point. Like, if you want to do feature play, then you probably can't really use Postgres very well. If you're willing and if you're bold enough to do actually requirement play. So look at, what does the project actually need from this relational database engine to be able to do, then my bet is in most cases, Postgres will be better. Mm. Better in the sense that it's simpler, that it is more agile, more versatile, less inherent complexity that you need to deal with where you actually don't want to deal with, etc., etc.
Yeah, yeah, it's alone documentation on create table in Oracle could impress the newcomers, like the amount of just documentation for a single statement. It's like,
but documentation really is a good thing actually, and Postgres lacks a lot of documentation.
Yeah,
lack of how-tos in the documentation and so on. So.
Yeah, well, I think Ilya is also talking to all of the features and functions around the create table statement that are available in Oracle that actually nobody actually uses. Because they are features ever once written for one specific customer in one specific use case, that they needed to satisfy for reason X, Y, or Z. And they built that into the product, and now everybody needs to deal with that.
Yeah,
which
exactly.
is.
Let's move to Kubernetes topic. We can. I wanted to try. I wanted to do it like smoothly, but it didn't work.
Yeah,
so
I wanted to ask. I have an idea how to move it smoothly. So basically, me and Nikolai, we sometimes we play like grumpy old school DBA and fancy new hipster one. You can guess in the comments which one I am. So basically, many old grumpy DBAs are resistant to Kubernetes and containers and configuration management and things like this. The others saying, well, it's so easy. It allows you to build complex architectures quite easily. You do not need to do everything manually. So to start with. What is the typical need? Why people starting to want configuration management, Kubernetes in particular, with databases, while they can simply just build a big database and manually manage all the things there?
My first take would be that you wouldn't necessarily engage in Kubernetes from a configuration management perspective, I think. It is more from, and perhaps it could be, my interpretation of the word management in that case. It is really from an architecture and the deployment kind of perspective, I guess. What I've seen, at least in the uptake of Kubernetes, really starts in dev test, or it started in dev test, where and that kind of requires you to look a little bit on where actually Kubernetes comes from and how that plays into application development and those kind of things. So to me, the reason why organizations actually start looking at Kubernetes as, apart from whatever they're going to run into that, is because they're moving into DevOps style IT operations. And then DevOps, not from, I'm going to do deployment automation or things like that, but more from the mindset, if I'm going to develop applications, I want to be able to add features and functionalities to applications quickly. I want to be able to deploy these changes quickly. So I'm going to break down the application. I'm going to take the single feature. I'm going to add it to my application, make it available to my users. Do that in an integrated fashion. So you get into this continuous integration, continuous delivery model. So the entire stack. And I had the opportunity to, together with Gabriele Bartolini, do a webinar a while ago that really, focuses on how do you start mapping DevOps best practices, and then DevOps from a mindset, DevOps best practices in an organization. And how do you then start looking at, okay, so now I have an application that fits in this new deployment methodology, but I'm still running a database that sits somewhere in the basement on a VM. And that's a big monolithic database that actually starts talking to this new, and I'm actually going to use the scary marketing buzzword, agile environment. That the application is actually running in. So you get like the disconnect where you're building new applications, new features, new functionalities. You're doing, 2 weekly release cycles. You're going to do CI/CD. I do a change, so I'm going to test it. The test is going to be released. One of the things I learned is that actually continuous delivery doesn't mean that you continuously make new features available in applications, but that your application is in the state that you can always deploy it. If you start thinking about that, that sets a bunch of requirements to that environment, which is fairly stringent. If you are in that mindset, but still run a database, which is this old, grumpy old DBA setup, there is a mismatch. And what you start seeing is that we want to start bridging that mismatch, and actually take that database from the VM, from this monolithic single database, and start thinking about how can we better bring the database closer to the application so we can get more alignment between new features, new functionalities, and things that live in the database. So it's also the start of this journey in that sense.
So like it looks like the idea you're trying to describe, as I understand, is like if application code is already in Kubernetes, database should go there too, right? To avoid these bridges.
Yeah, that is then a logical consequence of some of these decisions.
As far as I understand, yeah, the Kubernetes is like one of the way to do this. So basically, if the application is already in all these stages of continuous delivery, infrastructure as a code, et cetera, database definitely should be there. And doesn't matter if it is Kubernetes or not, but if the application uses Kubernetes, then it's obvious, yeah.
But it's much more complicated because it's a stateful thing. And for example, if we have a 10 terabyte database, like how can we build dev test environments with Kubernetes at this? Like, should we use smaller databases, or what do you think?
The question you could pose back is, if you think that's a problem in the new setup, right? I have a 10 terabyte database. I'm going to run that to support my new application or an application stack. I would still presume you would have, development, test, acceptation, production. So you'd still have 4 copies of that big database, right? Why would that differ if you run the database on a VM or if you would run the database in Kubernetes?
Right.
That it doesn't get bigger or it doesn't get more. You still have that one database that sits not on a VM, but on another kind of platform. If you look at how containerization actually works, you would even say, it could better sit in Kubernetes because the way a container is constructed is more lightweight than how a VM is constructed from pure performance perspective. A VM is a hypervisor on an operating system on a bit of hardware, where a container is actually, if you do it good, it is a part of an operating system actually.
Well, okay,
your mileage may vary.
Right, but like, is anything Kubernetes can bring for us to help with dev test environments? Like, I understand for code, it's like you basically have the same as on production, the same set of everything, right? Mm-hmm. But for databases, it can be tricky, especially if it's. I mean, let's talk maybe about Kubernetes versus managed services, right? Because sometimes people just offload this problem to RDS or Azure. I don't know, like Cytos, how they call it right now, not Cytos already, right? Mm-hmm. Hyperscale, right? And also new Aurora at AWS or new Alloy DB on Google and so on. It's just easier maybe to forget. But in this case, do we need to build some bridges again, because also dev test problem exists there as well, right?
I think, that's an interesting topic. One of the things I think is that, if you look at managed services or a Kubernetes implementation on site is a different discussion, right? Because you can have, let me rephrase that. If you have a managed service, you actually don't care how it's deployed. Because it's managed by somebody else. If you run Kubernetes, you say, I have infrastructure management in-house. I have that in my own hands. So one of the things that you then would say, if I would do that comparison, if you run in an organization that actually, is big enough to have this separation, an internal managed service, how does an internally managed service, where you as a DBA or a developer take compute resources from your internal organization, how does that differ from if you take these compute resources from an external supplier in that sense? How that then behind the covers is organized doesn't really make a big difference, I guess.
Yeah, well, one of the opinions I've heard, many people are actually quite suspicious about managed services, and they see Kubernetes as an alternative because basically they migrate from, say, Oracle DB2 or something like very enterprise and proprietary, and then they are feeling that they are locked in the cloud. which is true because it's much more efficient lock, yeah. And then they deploy their own cloud on Kubernetes. They feel like more free because, okay, we take all the free licenses and we use that ourselves.
That is absolutely, definitely another angle to that debate, right? If you say, I am now running Oracle and I feel locked, or I'm running DB2 and I feel locked, because the database is actually a closed source database and it's owned by IBM. And, I don't really like that. I want to move to something more flexible. I'm going to go to RDS or one of these other examples. Yes, you're going to a Postgres-like or a variation of Postgres, a distribution of Postgres, which is proprietary to, in this case, AWS. But you're also locking yourself into the infrastructure of AWS in this case. So you would go from a single lock to a double lock. If then you would say, okay, so I'm going to go run Kubernetes on premises, or as a private cloud setup thing, you would actually go from DB2, which is the single lock on the database software from IBM, to this place where you run a publicly governed open source database running on a publicly governed open source deployment technology like Kubernetes. So that is very much a distinctive difference, and another approach to why Kubernetes could be a good idea to run your database infrastructure on.
But there are managed Postgres providers like Ivan or ScaleGrid that can run your Postgres in fully managed way on any of three big cloud platforms, so AWS, GCP, and Azure. So in this case, vendor lock-in is doesn't feel so strict, right?
Yeah, exactly. This is what, to be completely honest, one of the things that so EDB Postgres also came with this tool called Big Animal.
I like the name, by the way. We definitely have a huge zoo already.
But one of the cool things is actually, and they're getting to that point. Currently available on Microsoft and AWS, but it's basically running full open source Postgres on one of these cloud infrastructure, but it's Kubernetes based, so you can also extend it to run on anything else, right? Where it's supported by, in this case, EDB, but in the end, it doesn't really matter if it's EDB managing that database. If something would happen, you would say, "Oh, I'm falling out of love with EDB and I need somebody else to take care of my database."
So I can connect. I can have SSH I can reach PG data. I can have a physical replication connection outside of this, to somewhere else, right?
Yeah, it's a Postgres database on AWS or Azure in this case. Yeah,
I've heard from one of popular managed Postgres services developer, one of the lead developers, that this is their biggest fear. Kubernetes is their biggest fear. And it was not RDS, it was similar to RDS, one of alternatives. And he admitted that Kubernetes is the biggest fears of when they think about future. So it means that Kubernetes should, in my opinion, also should probably start winning in some future over fully managed offering. But what you describe is it's combination. It's also feels like managed offering, but inside it's Kubernetes. So
Kubernetes is, at least in my book, is a set of technology, right? And if I'm using and perhaps that's the point that I wanted to make. If you run a fully managed service, you don't really care what it's running on. So it could be, even if your provider is running it on bare metal, what do you care? You have this fully managed service and you actually just use the service, right? If they run it bare metal, if they run it on VMs, if they run it on Kubernetes, if they run it on a Pi, for what I care, as long as you've got the connection, as long as the stuff is available and up to date as per the SLAs that you've created, that's fine. Kubernetes in that sense is just one of these deployment technologies, just like VMs would be, or bare metal, or an operating system would be.
I think details should matter here. For example, if we talk about clones of various kinds, for example, RDS provides cloning, and you should wait some minutes to have a clone, but you will need to pay separately for compute and storage of this clone. Aurora has thin cloning inside it, but again, you need to pay not for storage, I think, but only for compute. You pay additionally for I/O, but it's a different question. But in the case of Kubernetes, when everything runs in containers, pods, we can run multiple clones on the same VM and pay for just one VM. If you return to the topic of dev test, it may be very, very cost efficient, right? I mean, it's not a good idea for production to run primary and standby on the same VM, because obviously it's a very bad idea.
But for a test, why not?
I think it also depends on the way that your agreement with that provider stands, right? Because if you pay for compute cycles at some point, if you're running multiple pods, you will still use multiple compute cycles because you have more of these pods running, right? Then again, what you don't, or the complexity which you take out of it is that if you run VMs, for instance, the compute density that you get in a number of cycles is a lot higher because you don't have to run separate copies of the operating system, for instance. So that is, from a cost perspective, one of the benefits from using a solution like Kubernetes. But again, that I want to distinguish between how you do it and what you pay for it, to some extent.
So, like, it seems like we should spend some time to realize various ways to run that database in new world, because I also this Neon DB technology. Have you heard about it? It's like open source Aurora from neon.tech. I will put.
Okay.
So they released in June, like a month ago, and they develop open source version of Aurora. So they split compute and storage. And what I liked there is unlike Aurora. Also, they also have thin cloning, but since it's Kubernetes there as well, I think, I'm not sure, but at least it's possible for them to run multiple databases on the same VM. So user will pay only for one VM, because it's for dev test, it's important. I see it in our customer cases that they tend to combine multiple databases on the same VM for development purposes, because sometimes one database is not used for a couple of weeks, right? So here also serverless approaches may sound interesting because you don't pay when you don't use. So interesting.
Yeah, one of the things that you see there, and that's actually an interesting angle, is as you watch database technology mature, if you watch all of these kind of changes and new technology come to, quote unquote, our realm of relational database data processing. In the beginning, you just had, back in, the early 90s, this relatively simple database. You could store tables, you could store data, you could do queries, you could get it out. That started evolving, more and more features got added. And if you then start looking at Postgres and the Postgres community, that expanded, started growing. What you saw slowly is that you got more different angles to the database. The NoSQL bit came. There were enhanced features and functionalities. The entire geodata information system got added as an extension at some point. You got logical replication. You get all of these initiatives, and I think that's even. As Postgres gets more more loved and more used and you know, more prominent in the world, even more angles to the database get added. I think Kubernetes in that sense, or at least this deployment methodology is just another angle to the database. You've got the Neo, you've got the Graph, you got all of these new things coming to Postgres. A lot of different angles also to management and understanding around the Postgres database also, you know, start emerging. I think timescale DB, for instance, is also an interesting angle to that, because you get, you know, time series data. They could have started a new project and created a new database, but what they did is, you know, we've got Postgres as this strong foundation already there. Let's start building an extension to that. And I think we've seen more of these kind of extensions coming.
Sometimes not extensions. For example, Superbased, the same approach. Like instead of creating a new database, Postgres has a foundation, and it's like open source Firebase alternative, right? So with delivery of changes to application and so on. So the same approach. I agree.
Yeah, but you see, I now name extension, but we've also seen variations where projects have forked the Postgres database, and my take on that is that might not be the smartest way to go about this, because we all know that, you know, Postgres develops itself at light speed. If you really fork from it, being able to keep up with all of these changes is getting increasingly difficult. So, you know, managing and safeguarding that entire ecosystem of new requirements and new and changing ways in which Postgres can be used is going to be challenging for all of us to kind of make sure that we keep the core, you know, as resilient and stable as we're used to.
What do you think about which version of Kubernetes for Postgres is better today? Because we have multiple products already, like including open source.
It's a provocative question, yeah.
I think with what you see in this Kubernetes arena is also, you've got pure Kubernetes, so the thing that's built by the Kubernetes community, and then you get all of these enterprise versions like OpenShift, and like, you know, I think there are meanwhile a gazillion different distributions.
Right, but I'm an operator, for example. We have
okay.
Right.
I'm a little bit biased in that sense, because I've been involved in Cloudnative PG, the way that Cloudnative PG came about, and some of the considerations that, you know, were taken when the origins of Cloudnative PG were created. That basically, and I know that people don't all agree with what I'm about to say, but, you know, there you go. There are two approaches. The initial approach all the time was, you know, we're Postgres and we're going to take Kubernetes, we're going to bring Kubernetes to Postgres, and we're going to build an operator that runs Postgres and Kubernetes. The origins of Cloudnative PG, as Gabriele Bartolini talked about a couple of times, is really, we're going to take Postgres and we're going to take Postgres and bring it to this DevOps mindset, you know, and that is take Postgres and bring it to Kubernetes. That is.
Well, what's the fundamental difference between those two approaches?
Yeah, that's what I was about to try to explain.
Yeah.
So thank you for that. One of the things is, if you bring Kubernetes to Postgres, you will go about, or what we've seen and what, you know, originally was done in the predecessor for Cloudnative PG also was, you know, we're going to deal with Postgres in a Kubernetes environment, just like we would run Postgres in VMs. So we're going to use specific tooling to do high availability. We're going to use specific tooling to do backup recovery, monitoring, etc. Just simply one-on-one copy. The way we run Postgres in a VM, we're also going to run Postgres in Kubernetes. The fundamental difference with the other approach is, we've got this deployment platform, we got this application management platform, cluster management platform called Kubernetes. It's got the beautiful API server. It's got a lot of features and functionalities on whatever functionality required to be able to run applications in such environments. And what we're going to do is take Postgres and actually just take the stance like Postgres is an application just like other applications. It's got a few specific requirements. One of those would obviously be persistency in storage. And let's see to what extent the Kubernetes API server and the Kubernetes environment has capabilities to do this. By not defaulting to tooling, just using Kubernetes features and functionality. So what we've done is, for instance, high availability is implemented in Kubernetes using the Kubernetes API server. So the entire failover and switchover functionality that is part of Cloudnative PG is just using Kubernetes API features.
So no Patroni involved?
No, but that was actually one of the questions, literally one of the questions that we had when we launched Cloudnative PG. In what way do you use Patroni in Cloudnative PG? Well, we don't use HA tooling in Kubernetes. We just use the Kubernetes API features to, support streaming replication and actually do the failover switchover.
That might be challenging.
That has been challenging, yeah. But what it allows you to do is, what we've discussed a little just a few minutes ago is, if you look at Postgres, if you look at all of the development power that is coming to Postgres by all of these people that currently are adopting Postgres and looking at it and thinking, oh, but it could start doing this and it could start doing that, and we can build it in and around Postgres. That same energy you see in that Kubernetes community. It's also a publicly governed open source project, and there are potentially, I won't say more, but there are at least as many people involved in the Kubernetes project as there are in the Postgres project. So you get the same kind of drive of developers and admins. Wow, Kubernetes can do this for us, and if we tweak it like this and that, it can start doing such and so. If all of that combined energy is also already given to Kubernetes, wouldn't it be smarter to use that and ride that wave and have Postgres benefit from some of the innovation that's created in Kubernetes without us having to rebuild that in.
But maybe HA is just like single example of this. How about, for example, a PG Bouncer? You don't have an alternative for PG Bouncer in Kubernetes, right? Yet, okay.
Yet. That's actually one of the we talked about going from a proprietary world to an open source world. One of the profound things that I've learned is that in every question that you answer where you say, we don't do that, you can simply add the word yet, because if there is enough drive for it, somebody will create it, right? So if it is actually something that's interesting enough, it will come. Somebody will build it, simply. So
maybe somebody will build several versions of it, right?
Yeah.
In open source, it happens a lot.
Yeah. Yeah.
Like we see with the backups, for example. Yeah, now we have
several
options.
This Cloudnative PG product, what does it use for backups, for example?
Basically, what it now does is just S3 storage. So it has it uses an S3 interface. But there is you also have the ability to use Barman Cloud. So in that sense, there are also angles where you would say, still, because Kubernetes doesn't do it yet, or perhaps it will never do it. There are specific things that would still require additional tooling, but for standard backup recovery, there is provisioning in the operator to do backup recovery. But for more advanced use cases, there is the ability to use specific open source tools. So that's part of that continuous development. And then coming back to a load balancer or at least a connection pooler, you could envision that at some point becoming part of something like a data mesh or a networking mesh that is inside Kubernetes, because that same functionality would not only benefit Postgres, but it could also benefit other specific storage entities that would start living in Postgres as we move forward.
But it would be good if this thing supports Postgres protocol, of course, right?
Yeah. And the interesting angle for that is there is actually a data on Kubernetes community, which specifically focuses on running stateful workloads in Postgres, which is run and supported by the CNCF. So for anybody having concerns in that area, they're obviously extremely welcome to join the data on Kubernetes community as well.
What about monitoring? Should it be the part of this product, and what happens in Cloudnative PG already in terms of monitoring?
That's a super interesting topic, because I think in that case, one of the things I think we should realize is that there is two angles to monitoring. The first angle is the operational monitoring, where Postgres again is just an application running on Kubernetes, and there is basic monitoring by means of do I have my pods running? Is my stateful workload? Is my backup running? Is all of the generic Kubernetes-based material, is that available? But this isn't Postgres specific, right? Because if you've got an application that runs 50 instances of JBoss, for instance, you also need to monitor and manage that, just like you would do your 5 instances of Postgres, for instance. Monitoring of Postgres also has another element to it, because it's actually a living thing. An active database is a living thing. So you also want to monitor inside that database the Postgres domain specific features and functionalities like memory. How is memory management? Do I have, deadlocks? Do I have, what are the number of locks in the database? How is
transaction wraparound, transaction ID wraparound, right?
Transaction ID wraparound. Yeah, those are things that are specific to Kubernetes. So in my idea, they wouldn't run into a Prometheus Grafana kind of setup for Kubernetes monitoring, but you would have like a Postgres domain specific monitoring orchestrated to keep a tab on your database and how your database is functioning. So that, in my opinion, would be a different way of looking at that realm.
So basically, that famous Kubernetes initial idea that database service could be run, every software could be run as a pod, and we can simply check the status of the pod. If it doesn't work, we just switch it off and reinstantiate the new one. So it's not that easy with database still, and maybe will be never achieved. or?
I think, if you start looking where, and I agree with you that we're in very early stages with this, and nobody knows what the world, back in the day, you couldn't say what the world would look like next year. I think today you can't even predict what the world's going to look like in 2 months. With the speed a lot of this development is going. Running Postgres and Kubernetes isn't as new anymore as when we started it like 2 or 3 years ago. Then it was absolutely not production ready. I think we're now at a point where it's production ready, and actually a lot of people are running this stuff in production. It is getting to be more like, it's built to be broken. And if you just shut down a master pod, the operator will spin up or will promote a standby pod to be the new master, and it will just continue running. That's not very much different than how a VM is implemented these days, right? And that will start improving as we move forward. So I think we're a little bit at that point, what you said, but it's got quirks because it's a stateful workload. And through the doc community, through the, comprehension of what stateful workloads on this volatile platform actually mean, big steps forward are being made currently to be able to achieve those kind of things. So it will get easier as we move forward.
Yeah, it's a good point. Okay, so we slowly running out of time. So let me suggest some sort of wraparound. If we are talking about like an average technical manager or a DBA, what sort of the main directions those people should address if they're trying to figure out if they still stay on the bare metal or VM or something like this, or they need to try Kubernetes? Which way to go? Like three major bullets they need to tick to figure out what to try and where to experiment.
But then I think the very first bullet is just simply determining, is this something that you're going to build completely new from ground up? So is it actually greenfield new application? Because if I were an IT manager and I would now want to start a completely new project, build a new application with a new setup, I would definitely choose Postgres as my database. That goes without saying. And I would probably want to start building up my application in smaller increments. So I wouldn't have to spend, first a year and a half programming and testing and whatever to come to a first MVP, minimal viable product. So I would want to, build something, get that out to public as soon as possible, which would kind of put me in that, DevOpsy application development area. So that would be one.
And that's obvious. That's obvious. You take Kubernetes and try the native things. Yeah.
Completely the other side of the spectrum. If you are currently running, a major monolithic banking application or an insurance application, which is running a mainframe DB2 database with a big COBOL, application layer, I wouldn't necessarily then, think first of Kubernetes as the platform to start running the migrated database on, right? That would take a longer project, a longer set of iterations to come to somewhere that you would have to make a couple of significant steps to come to a more modern infrastructure. So you might then want to think, perhaps I need to even, first start setting up some x86 servers with just a Linux operating system and start running a database, so I can actually get away from the mainframe database to something which is a little bit more manageable. before you would go to a Kubernetes environment. So that would be the two extremes. And then from anywhere where you're in the middle, just running Kubernetes for the sake of running Kubernetes, I think is not the best motivator to start doing it. And still that happens. And that is also not necessarily wrong, but it's not perhaps the best driver to do it for the sake of doing it. If it's something, we've worked with a customer that said, we run applications on Kubernetes. Postgres is an application, so it needs to run on Kubernetes. Then you've got a business requirement to run Postgres and Kubernetes, and then that's good, right? So we can now actually fulfill that because it's possible. To do that just because what I said for the sake of doing it wouldn't necessarily be a recommendation, I guess.
Or at least we can try that.
That's definite. Yeah. On the other hand, it could be the first step into the direction if you say, I'm going to indeed put my dev test environment on such an infrastructure, because then at least I can get it going, right?
Yeah. Yeah, great. That was really interesting. So we managed finally to make some more general view of this landscape, and thank you, Jan, for that. I hope it was interesting. So basically, if anyone who watch us not live but as a recording have any questions, you can just put that into the comments, and we forward that to Jan and try to answer.
Right.
So, and as usually we say, you always can subscribe to the channel to get the recent updates. What else? What we have to add?
Subscribe and share the links in your social networks.
Yeah, of course.
Thank you, Jan.
So thank you, Jan, and
You're
that
welcome.
was a pleasure to talk to you.
As always, thank you.
Thank you.
Bye-bye.
Until the next time. Bye.
Yeah.